Okay, okay. So we're going to begin. We're going to start from where we ended last time. Yeah, so before we begin, we're going to pray. Shall we pray? Our dear Heavenly Father, come before throne of God. I'm asking you to impact in me wisdom so that I may be able to teach and also understanding into my students, oh God. In the name of Jesus, I pray. Amen. Yeah, so without wasting our time, today we're going to try to finish off this chapter, the last chapter. Then after we finish it off, we're going to try to solve some questions. Then it will be it for today. Yeah. So solve some questions. Then after that, I will give you some work to do. Yeah. Some homework. So yeah, so last time we were talking about the charge, what the charge is. We talked about the positive, the negative charges. Those are the things which we are looking at. We talked about uh, when you try rubbing something, like when you try rubbing a non-metal on the floor, you create some charges are transformed to that non-metal, and that non-metal, the rod will become charged. We talked about the glass, the plastic, the glass is charged. We talked about that the glass is charged positive, the plastic is charged negative, and yeah, and those are the things which those are the things which we looked at. We also looked at the distribution of charges. When you have a lot of charges which are when you've got a lot of charges which are distributed on one point, how do you calculate the density distribution? Yeah, we looked at that also. So we looked at different formulas about the distribution. So we looked at the density volumetric, the charge, where we use rho is equal to dq over dv. Then we also looked at the density surface, the charge when there was a cloud of charges on the surface. We looked at the formula which we use. This is a sigma is equal to dq, which is the differentiation of the charge over ds, which is the surface where you can find those charges. It's a distribution, a cloud of charges, meaning you can't really know where the charges are. That's why we use dq, which is differentiation q. Then also looked at we also looked at the charge lineage, where there are a lot of charges, a cloud of charges, density lineage, the charge where you see a lot of cloud of charges which are on a what which are presented I can say which are on a line, and we said that their formula is lambda is equal to dq. dq is the number of charges, the cloud of charges, the quantity of charges which you don't know, which you cannot count, divided by the air, which is actually the length where those charges are found. So we looked at the distribution of charges. Those are things which we looked at. So this is just a rappel. So today, basically, we're just going to finish off with the last part, which is the first column. So basically, we're going to look at the forces. How does the forces react when you have? How does the forces the interaction of forces when you have two things which are charged? What usually happens? So we're going to look at in details, and we're also going to look at the formulas which we use to calculate the forces. So I don't know if you are able to see my sharing before we begin with today's the last part.
Yes, we can see.
Okay.
Yeah. So today, basically we're going to talk about force, and force. It's not something new, actually. I can say so. It's not something new. It's something which we have already learned in secondary school. And when you talk about force is something which acts on the other thing, like you cause a force when you introduce or you act on something. If you act on a surface, you like you are causing a force on the surface. There's an action which is I can say an action which is put towards something, which is that's I can say that's the simplest way to talk about force. So when you talk about force, actually we're going to talk about how one charged particle acts on another charged particle and what will be the resultant, what will be the effect of one charged particle acting on another charged particle. So here, when you talk about force, actually we are going to talk about force the column. Force the column is basically the force which deals with the charges, the positive, the negative charges, and column. You know that column is the unit which is the unit for charge is column most of the time. Yeah, the unit for charge is column. So here we're going to basically when you hear the force, the column is basically we're going to talk at we're going to look at the forces which are caused by one charge. The forces which one charge causes onto another charge, and what is the resultant, what is the reactant if those forces they are if one charge particle cause an action on another charge particle, what will be the resultant? That's what we're basically going to look at. So we start here. It says on considérait des particules chargées, on considérait des particules chargées ponctuelles. So punctual, when I talked about punctual, basically they are just talking about charges which are, I can say, charges which are isolated in such a way that charges which you yourself you can see, charges which you there's a difference between density distribution. Density distribution is a cloud of charges where there are a lot of charges in such a way that you cannot count and you cannot know where this charge is. It's like the charge is found everywhere. That's the density distribution. There's a cloud of charges where a charge can be found anywhere. And when you talk about charge punctual, actually, we talk about a charge which you can be able to the charge which you can be able to point out, which is isolated. I can say so. It's not found everywhere, but it's isolated and is fixed at is only found at a certain place. So so you see these two things like when you are doing when you are dealing with questions, you see these two things coming in time. Yeah, you will see them. They will be repeating. We say distribution, density distribution, or we say charge punctual. You see that when you talk about charge punctual, we talk about charges which are fixed, charges which are not found everywhere, like you can be able to point out. But when you talk distribution of charges, we talk about charges which form a cloud, and these charges, they are found almost anywhere, and for you to calculate this charge, you have to do some differentiation, which you are going to see when we come to do the questions. You are going to understand it more. So here it continues saying that C1, the charge C1, the charge Q1 situé on point M1. So they want here, they just want to explain to us there's a particle which is named C1, which is this side here. If you see the diagram here, this is a particle which is named C1, and imagine it has the charge of what? Q1. This is the charge of Q1 situé on point M1. So this is a point M1. So this one, if we talk about charge punctual, they have a fixed point. They have a point where you cannot find them everywhere. They will specify the point that they are found on point M1, point A, point B, and there's also a particle which is what C2, the charge Q2. You have a particle which is C2, which is charged what Q2, situated on point M, which is situated at the point what M2, which is M2 here. So you see that there we've got two particles, and these particles have got what charge. They have got charges. The one particle is charged what Q1, and the second particle is charged Q2. And these two particles, they are in a way that you know that if you bring two charged particles together, there will be either an attraction or repel. So you see that if you bring these two particles together, Q1 and Q2, depending with the sign of Q1 and Q2, you see that there will be either an attraction and or there will be either an attraction or repulsion, where you see two things are repelling, like they're separating. So yeah, so basically here that's what they're talking about. You have got two particles which are charged Q1 and Q2, and on a pair R, la distance M1 and M2, and we have got R, which is the distance between what M1 and the M2. So you have got two charged particles, Q1, Q2. The distance between two charged particles, which is M1 and the M2, which is here R is equivalent to M1, M2, which is equal to the module of M1, M2. This is what R. So this is the distance which separates two charged particles. So so basically here, just for the first part here, just know that when you have two charged particles, there's either attraction or repulsion. So we're going to look in detail what happens if there's an attraction and what happens when there's repulsion. So yeah, so when we go down, we're going to look in details, and for you to calculate the force which is caused, since you know that there's always a force when there's an attraction, there's always a force which is causing it to attract, or when there's repulsion, there's always a force which is what causing it to repel. So what is that formula for the force? How can you calculate the force? So for you to calculate the force, we have an expression mathematics, which is force vector. This is the vector force 1 to 2. So here, when you see 1 to 2, you should always note, when you see 1 going towards 2, it means that the force is caused by this charged particle, which is 1, towards the charged particle, which is 2. So there's a force which is created, or there's a force which is created by Q1, which cause Q2 either to move away or to be attracted. It depends with the sign. If it's positive sign, it will cause Q2 to move away. If it's a negative sign, it will cause Q2 to be attracted. So basically, it depends. Most of the time, it depends with how the question they'll phrase it. The question, they can phrase the question, they can say, calculate the force, the vector force where 2 towards, imagine here there's 2 where there's 1 towards 1. So it means there's a force which is created by the force, the particle which is creating the force is Q2 towards Q1. But in this sense, is the one which you have here is the charge 1, Q1, the particle 1, C1, is the one which is creating the force on Q2. That's why I'm saying there's force 1 to 2, which is equal to K, which is a constant, times Q1. Q1 is the charge, the charge for the first particle, times Q2, which is the charge for the second particle, divided by R squared, which is the distance between M1 and the M2. Then times the vector, which is 1 to 2. So the vector is moving from, since the force is created, Q1 is the one which is exerting force on Q2. So the force is created from 1 to 2. That's why you are seeing the vector U is equal to 1 to 2. So here, that's what they are explaining here. So this is basically the formula which you should have by heart. Like, you just have to know it when they tell you to calculate the force, either when the charges are in distribution, the density distribution, where you can find the charge everywhere, or the charge are punctual, where a charge is fixed, where it has got a fixed point. For example, here you have M1 and M2. M1 is a fixed point for charge 1, and M2 is a fixed point for charge 2. You can use the same formula where you just replace Q1 and Q2, which is, they give you basically most of the time in your what, they give you most of the times in your questions, what is your charge 1 and your charge 2, and they also give you your distance between the particle C1 and the particle C2, and with those information, you can easily calculate the force. Then K is always the same. K, you just have to know it by heart, is a constant which is always the same. No matter what, your K will always be what? The same. So here, as I was explaining, you see that force, which is 1 towards 2, a vector force 1 towards 2, désigne la force exercée par le charge Q1 sur le charge Q2. So the force which is from 1 to 2, it denotes, or it defines the force which is exerted, which is I can say exerted or exist. Yeah, which is exerted by the charge, which is, I can say another term, which is as I said, the force which is Q1 acts on what Q2 is. The Q1 is the one which is causing the force on what? On Q2. Exerted in English, the word has gone, but something which is, it exists, like it causes an action. So we see that the force exerted by the charge Q1, the force exists by the charge Q1 so the charge Q2. So it's a force which is caused by the charge Q1, which is here the particle C1, so the charge on the charge what? Q2. So here is Q1, which is what? Causing the charge. It's the one which is exists, which is what? Which is I can say which is causing which is causing an effect on charge 2. In other terms, which is causing an effect on charge 2. Then you have got U vector 1 to 2. This is a vector which is towards what? The vector. So this vector depends where the charge is being exerted, or where the charge is being exerted. Where the charge is being caused. So you see that the charge is Q1 is the one which is causing the charge on Q2. So you see that the vector, it will be from 1 to 2. The vector will be what? From 1 to 2. And when you are taught to write your equation, you present it 1 towards 2, because the force is caused from is Q1, which is causing the force which is exerting the force to Q2. It's Q1 which is exerting the force to Q2. So you see that your vector, it will be from 1 to 2. Then K, as I said, K is a constant. K in constant derive the epsilon 0. So K is a constant which is a derivative of epsilon 0, and you don't K is equivalent to 1 over 4 pi epsilon 0. So this one, you just have to have it in your, like you just have to know it. You just have to know it. This one, 1 over 4 pi epsilon 0, which is equivalent to 9 times 10 to the power 9 Newton per meter squared times column negative squared. So this is the formula which you have to know. So the K, on K, you can either replace it with 1 over 4 pi epsilon 0, or you can replace it by 9 times 10 to the power 9 Newton times meter squared times C negative squared. So that's, yes, you have a question?
Yes. I just wanted you to repeat the previous statement on the U.
Oh, okay. So like as I said, the first one is force, which is 1 to 2. Désigner la force exercée par le charge Q1 sur le charge Q2. So when you talk about force, it is 1 towards 2. It defines the force which is exerted by the charge Q1 sur le charge Q2. When I say exerted, exercer, in French is exercer, and in English I think it's exerted. Yeah, some English words stated. Yeah, so I think there's not much difference. So when I say exerted, it means cause, which you cause, exercer is a cause. So when you see force 1 to 2, you know that it is the particle C1, which is exerting a force on Q2, which is the one which is causing the force on C2. So you are moving from 1 to 2. So you see Q1, which is exerting the force. Then when you see vector U, 1 to 2, is just showing the direction where this force is being the direction where the force is being exerted to. So where is the force exerted to? Is exerted from Q1 to Q2. Yeah, so the force is exerted from Q1 to Q2. So your vector, you are moving from 1 to 2. So this is just a vector which is showing you where your force is, where your force is being exerted. Then K at your constant. K is a constant where.
Excuse-moi.
Yeah.
So if it was moving from Q2 to Q1, it will be 2 to 1.
Yeah, if we see 2 to 1, for example, if your force, they tell you to calculate the force at 2 towards 1, so it means you're moving from Q2 going to what? Q1.
All right.
So if it's from charge 2 to charge 1, it means your vector, your direction here will be 2 to 1. I don't know if you are getting me.
Yes. Okay. Thank you.
Then the constant is always 1 over 4 pi epsilon 0. That's the constant. This one you just have to know it by heart. That's the constant. It's always I can say it's always what? It's always it will never change. It will be always the same one. Like in any question which you are given, it will always be the same one. The constant never changes. Yeah, so I don't know if there's anyone with any question here. So you should also know that since R, they have said is M1, M2, then you should also know that U1, when you're moving from 1 to 2, is just the same as this is I can say this is a formula which you just have to know by heart. There are no modules. Just forget this. So U1 towards 2, you just have to know it's just the same as M1, M2 divided by vector M1, M2 divided by M1, M2. But this one actually is not really important, yeah, but you just have to know that when you're moving from one to the direction, the vector direction 1 to 2, u1 to 2 is also equal to, this one just have to know by heart, is equal to the vector of the distance, which is m1, m2, divided by m1, m2, which is the module, just the same as the module. So yeah, so that's what you should know. The vector of the vector 1 to 2, u1 to 2, which shows the direction, is equal to the vector of the distance, which is m1, m2, and the module of the distance, which is m1, m2. So this one is a formula which you have to know, and you understand it better when we start doing some questions. That's when you understand it better. I don't know if there's any questions here. Yeah, so if there are no questions, we're going to go to propriété important, some important properties of these charges. You have to know these properties for you to be able to for you to be able to solve questions concerning the charges. You have to know how they move, what happens when two charges they come together. You have to know all those things. If you don't know, it will be really difficult for you to calculate, to be able to calculate different when you're given different scenarios. It will be difficult for you to do the calculations. Yeah. So there's a first part. So these are different ways in which the charges can be the different ways in which the charges can be oriented. So you can have a positive charge and a positive charge. So when you are a positive charge cause a force on another positive charge, you have repulsion. That's why you are seeing that there's an arrow here, which is what going outside, and this arrow is, if you see here, you see force. The force which is a force which is caused here on Q2. So you see Q1 is the one causing the force here on Q2, and the Q2 is moving what outside. So you see here that you have force 1 towards 2. So which just says that the force which is caused by Q1 towards Q2 in such a way that Q2 what goes like it gets repelled. It goes there's repulsion which is taking place. Then there's also here, if you see here, there's also the going outside, and your friend had asked a question, if it is the other way around, is it going to be the direction, is it going to be 2 to 1 or the force 2 to 1? It's the same thing here. Here is Q2, which is causing the force on what? Q1. That's why you're seeing the force is 2 towards 1. So you see that there will be a repulsion. So if there are two charges, two like charges, you see a repulsion. There will be a forces electrostatic repulsive, meaning there will be some separation. It's just the same thing with negative. There will be also what some repulsion. If you have positive and negative, you see there will be what some attraction. That's why you're seeing these arrows. They are coming what inside, meaning these two particles they're trying to come together because they are of different charges. So if you have got different charges, you should know that the force which will be created there, it will be an attraction, which is the coming together of the two particles of different charges. So that's what usually happens. So this is important in such a way that you'll be given a diagram. Yeah, you'll be given a diagram, and they give you that, maybe they give you this particle is positive, the other particle is negative, and the other one is negative. You have to know how to draw the vectors, the line for forces. It's really important. You have to know to draw the line for forces. if it's positive, you have to know that the force is going outside. If it's negative, positive, you have to know that if, again, in simpler terms, if it is the same signs, you have to know that the forces are always going outside. But if it's if it's of different signs, you have to know that the forces are coming inside. So that's what you have to know. And if you know that one, you won't have any difficulties when it comes with the calculations. And also, you should also know that this one is just a diagram here. When you see the diagram here, you should know that the more you increase your R, the more your force reduces. Here is logic. You have seen your R squared, which is the distance between the two charged particles. You have seen that you are dividing, like you are doing a division here, and you have got a constant which is always the same. So when you are always the distance between Q1 and Q2, you can get an example where, for example, if the charge Q1 is +2 and the charge Q2 is +3, when you increase the radius between, you increase the distance between these two charges, you find that your R will become more bigger and bigger, and your Q1 and Q2 will still be 2 and 3, and you see that your graph here, it will be your force here, it will be what? Reducing, and you see that the more your R becomes bigger, the more your force becomes small. Yeah, so it's like it's inverse proportion, where when the distance becomes bigger, the force reduces. So that's just I can say you just have to know that, and I can say it's just logic when you are dividing with something, and if that thing which, for example, that thing which you are dividing with, the moment it starts becoming bigger, you see that there will be the value of your final answer will also start to reduce, as long as the values on top remain constant. So yeah, so that's it. So I don't know if there's any question here. If you have any questions, you can ask.
So on this one, we can conclude that the bigger the distance, the weaker the force.
Yeah, that's true. The bigger the distance, the weaker the force becomes. Yeah, because when you increase the distance, when your R increases, the force reduces. So yeah, so that's true. The weaker the force, the greater the distance. So where there's a large distance, or where the distance is bigger, the force is small.
All right.
So the principle, the superposition. So now our principle, we're still on the properties, is some important properties. So principle of superposition. So here, under principle of superposition, actually, we're just going to talk about there's one charge, and this one charge is, there are a lot of other charges which are exerting a force on it, which are causing a force on it. So what do you do? How do you calculate the force total of that charge, the force which is exerted on that charge? So so here it says principle de superposition. On considère une particule chargée qui exerçait une influence sur la particule A. On a FA is equal to F. The force, this is force total, is equal to the force which is caused by one charge plus the force which is caused by another charge on this force, plus the force which is caused by another charge, until so on. So it's just the same here. If you have a particle which is, if you see this diagram, you have a particle which is in the middle here, and you have got different particles which surrounds it. So for me to calculate the force which is created here, how do I do it? So for me to calculate the force which is created here, you see, the force total is equal to the force which is created by Q1, the force which is caused by Q1 on Q, plus the force which is caused by Q2 on Q. Since I'll calculate it's like it's like you calculate one force for one particle and another force for one particle, then you add them together. So here, the one which is affected is the one which is on the middle. So we see here that, for example, here there's a charge Q1 and charge Q2. So force total is equal to force 1 plus force 2, which is equal to force 1 is equal to constant. I said this one is always, it will always be the same, it will never change, times Q1. Q1 is the one which is causing a force on Q. Times Q1 times Q, where you cause the force, divided by a distance, the distance which is between Q1 and Q. Q1 and Q, which is we'll call it x1 squared, then U1 vector. So when you should not confuse it when you can, there are two ways how you can write your vector. You can write your vector just writing U1. When you write U1, meaning you are starting from Q1 going to the other particle, or you can write U1 towards 2. It doesn't matter. What matters is what you put first. So what you put first, that's what shows where you're going. So for example, here they've just written vector U1, which means that they're starting from Q1 going to Q. So if you want, you can put U1 towards what? Towards since here in such a case there's Q1, Q2. Here, if you want, you can just name it 0. So 1 towards 0. It depends with you, but if you just in this case where you have got a lot of charges, you only show the first point where you are starting, where the force will be, where the force is coming from. So here the force is coming from Q1. That's why they have showed only they have written U1, which signifies that the force is in a direction from what U1 towards what Q. Then plus there's Q2 here. Q2 here is exerting the force on what? On Q. So we see here that there will be Q2 here supposed to be Q2 times Q divided by this is R2. Sorry, this is not X, this is R. Yeah, this is R2, 2 squared. So your R2 is just the distance between Q and what? Q2. Yeah. Times the vector, which is what? U2. U2 meaning I'm starting from this part, Q2, going to what? To Q. So that's how basically most of the time we are represented. If you are told to calculate the force at a certain charge and that charge is being exerted by different types, I can say different, I can say is being, that charge is being, there's a force from different other charges which is being exerted on that charge. So you have to know how to calculate each force. So see here, in this case, the way they calculated their F1 and F2, they imagine that Q1 is positive and the Q is positive, Q2 is positive, and Q is positive. So if Q1 is positive and Q is positive, it means that when Q1, this is, if you see here, there's an arrow here. When Q1 exerts a force on Q, there will be repulsion, which will cause what? F1, which is the force of going outside. Then when Q2 exerts a force on Q, which is positive, there will be a repulsion, which will cause what? A force, which is what? F2. Then for me to calculate the force total, now I have to calculate the force total is force 1 plus force 2, which is here just you just extend here. They have just done the extension of this line. they have drawn an extension which is parallel to this line and an extension which is parallel to this line, where they are cutting, they have made something like a rectangle. And you see here that there's this is a force total. This is the force total which they are looking for, the force total which they are looking for. So for you to calculate the force is force 1 plus force 2. Force 1 which is created with Q1 and the force 2 which is created by Q2. I don't know if it's clear here. Is there anyone with any question here?
Repeat, magnetic was cutting.
What?
Magnetic was cutting. Repeat once more.
Okay. So basically I was talking about the principle of superposition. So when you hear the principle of superposition, it's just different when you have different particles which are charged, causing I can say exerting a force on one charge. So how do you calculate each force total? So here we're just talking about the calculation of force total. So I said for you to calculate the force total, you have to for you to calculate the force total, you have to calculate the force of each particle which is caused on the particle which you are studying, which is Q here. So the force of the force of each particle which is caused on a particle which you are studying, and you add them. So here they have said that the force is exerted on Q. So meaning Q1 is exerting a force on Q and Q2 is exerting a force on Q. So Q is the particle which we're going to study in terms of what force is when these two charges, when they create a force or when they exert a force on Q, what usually happens? What total force are we going to have? So we see here that when Q1 exerts a force on Q, when Q1 exerts a force on Q, and we said that the way they draw this one, they imagined that Q and Q1, Q and Q2, they are all positive. So when Q1, this arrow is showing that it's exerting a force on Q. When Q1 exerts a force on Q, what you see is that the force will be a repulsion, and when there is a repulsion, there will be a force which is F1, which is like moving outward, which is like wanting to separate these two, a force which is wants to separate these two, which is F1. Then when Q2 acts on Q, you see that there's a force also of repulsion, which is F2. Then for them to find the force total, they just have to find the module of F2 and F1. How do they find the module of F2 and F1? They just extend the line which is parallel to this line, which is the force F2, and the line which is parallel to the force F1. When they are meeting, they will make something like a rectangle. Then you draw this line represents your force total. This is your force total, which is the addition of F1 and the F2. So I don't know if it's clear. Then these are the equations. So here you just replace where there's F1 and F2, just replace with the equations which we have looked at here. Yeah, this equation here. So this is the equation. This is the equation of you to find the force. So this equation, you just have to know it. I don't know if it's clear.
Yes, it is.
Yeah, so you understand it more when you start doing questions. You understand it more when you do some questions. So we're still on the propriety importance. So here they're just talking about the same thing. If you have in this case, if Q prime is greater than 0, meaning when you multiply Q and Q prime, you get your answer which is greater than 0, meaning you are multiplying a positive and a positive. When you multiply a positive and a positive, toujours, always you are going to have what? you are going to have your answer which is greater than 0. So it's of the same sign. If it is of the same sign, if Q exerts a force on Q prime, you have a repulsion where you have F prime, the force F prime, which is going outside. If Q prime exerts a force on Q, you have the force which is F, which is going what? Outside. But if you have Q times Q prime, which is less than 0, meaning when I multiply negative value of a positive charge and negative charge, I always have an answer which is negative, and the negative is less than 0. So what you see is that if Q prime exert a force on Q, you see that there will be if Q prime exert a force on Q, you see that there will be an attraction, which is the force F. That's why I've seen that it's going inside. But yeah, and also when Q exert a force on what? Q prime, you see that there will be an attraction. That's why you're seeing what? F prime, which is what? Going inside. Yeah, so basically those are the things which you have to know, and if you know how to interpret those things, you know how the arrows. So the most important thing is when you exert a force on something else, where do the arrows go? So you have to know if it's positive, if it's of the same sign, the force has to go outside. So yeah, the force has to go what? Outside. And if it's of the different sign, the force has to go inside, like they are coming to what? To attract. They are coming together. Yeah, so that arrows mean the force is the force which maybe the force which Q prime or Q possesses is the force of attraction. If you see an arrow, a force which is going outside, it's a force of what? Repulsion. I don't know if it's clear here. Is there anyone with any question? Before we go to somewhat, we solve some TD. Is there anyone with any question?
I guess no.
Quoi? Today quoi? I heard someone saying something.
I guess no.
No, okay. So before we go to our question, I want you to yeah, I want you to know this formula. Like I want you to just look at this formula. Then since it's the formula which mostly we'll be using, we'll be just changing depending with the question. So this is the formula which when you come at forces, this is the formula which you usually use. So this formula, you have to know it. It's really important, and you have to know what your K is. Your K is equivalent to 1/4 pi epsilon 0 epsilon, which is equivalent to 9 times 10 to the power 9 Newton per meter times meter squared times Coulomb negative squared. So this one also you have to know it. You have to know for the force. Force is equal to K Q1 times Q2 over R2 U1 towards what? U2. So now we're going to do some questions. Are you able to see my sharing? Are you able to see my sharing?
Wait.
Yeah, so I decided to do questions on we'll do about 3 exercises. Then I'll give you homework to search for 2 exercises, which I want you to search. Yeah, there are 2 exercises which I'll give you at the end of this. So we're going to start with exercise 1, which is charge punctual. And I said charge punctual are charges. When you see the word charge punctual, if you know that there are charges which are they are fixed, you know where they are. There are charges which you know where they are, and they have got, I can say, they have got a fixed point. They are not charges which you find everywhere or at all places, but there are charges which are just what fixed, and you can easily point them out. You can easily, you can easily identify them because I can say they're isolated. In other terms, they are isolated. So we have exercise 1, which is under charge punctual. So here the question, the what it says, 3 charges Q1, Q2, and Q3 sont disposés selon les figures ci-dessous. So we have got 3 charges, which is Q1, Q2, and Q3, which are disposed according to this figure which you are seeing here. So I've got these 3 charges. Then calculer la force résultante appliquée sur la charge Q3. So they are saying that calculate a force, a resultant force which is applied on the charge Q3. So here, if I ask a question according to the way they have written it, they have said there are 3 charges, Q1, Q2, and Q3, which are disposed in this figure which you are seeing here, and they are asking you to calculate a force which is applied on charge 3. So what does it mean when they ask you to calculate a force which is applied on charge 3? And if I ask you a question, here, which charge is being affected? Which charge, since we have got about 3 charges here, there's Q1, Q2, Q3. Which charge, where is the force exerted? Is it, where is the force exerted? Is it exerted on Q3, or is it exerted on Q1, or is it exerted on Q2? Someone to answer me? Since they have saying calculate the force resultant appliquée sur la charge Q3. So where is the force exerted? Which charge, I want to tell me on which charge is the force directed? Is it on Q1, Q2, or Q3? Someone to help me?
On Q3.
What?
The force is exerted in Q3.
Q3, yeah, correct. That's, yeah, excellent. So we see here that as our friend has said, the force is being exerted on Q3. The force is being acted on Q3. So you see that there's Q1, Q2, and there's Q1 which exert a force on Q3, and the Q2 which exert a force on what? Q3. So they want you to calculate the resultant force. When you see, like according to the question, they say resultant force which is appliqué sur la charge Q3. So for me to calculate the resultant force, it means I have to calculate the force which Q1 exert on Q3, and plus the force which Q2 exert on what? Q3. It's just the same thing with the example. So they have even given you on données, they have given you that your Q1 is equal to positive 1.5. So point basically most of the time in the French system, when you're writing points, you don't need to write like our English system where you write a dot or what. When you're writing a point, is a comma. So you have 1.5 times 10 to the power negative 1 column, which is Q1. They have given you already Q1. Then Q2, they have said is equal to negative 0.5 times a dot in what? In the French system, it signifies multiplication. So when you see a dot, when you see you see sometimes I put the multiplication sign, the actual multiplication sign, which you know, or I can put a dot. It's just the same thing. It means multiplication. So negative 0.5 times 10 to the power negative 3 columns, which is the charge Q2. And Q3, they have also given us its charge, which is positive 0.2 times 10 to the power negative 3 what coulombs. Then they have given us the distance SC. SC, they have given us the distance which is 1.2 meter, and BC, they have given us the distance BC, which is what 0.5 what meter. Then they want us to calculate the force which is exerted. The force which is what? The force which is created on Q3, or which is exerted on what? Q3. So how do you calculate the force? So first of all, you have to see the charges. If you see Q1, Q1 is positive. This is positive 1.5 times 10 to the power negative 1. Q2 is what? Negative 0.5 times 10 to the power negative 3. Then Q3 is positive. So you have got it positive, negative, positive. That's the first thing which you have to note. So after you have noted that one, so this one don't pay attention to this one. I've made a mistake. So we're going to deal with this diagram here, which is here. So after you have noted that Q1 is positive, Q2 is negative, and Q3 is positive. What do? Now you have to represent it in your diagram. So how do you present it in your diagram? You know that your Q1 is positive, your Q3 is positive, your Q2 is what? Negative. So what happens? So we have said that Q1 is the one which exert the force on Q3. So when you exert the force, meaning it's coming from Q1 to what? To Q3. So what happens when you exert a force which is in a direction from Q1? So it's vector U1. So this one is showing the direction which is exerted towards what? Q3. What happens? Since it's positive, when you exert a force on Q3, you see that you create a force 1 which is going what? Outside, because there will be a repulsion which is taking place here. Then when you exert a force Q2 on Q3, you see that since Q2 is negative, Q3 is positive, you have a force of attraction. That's why I'm saying that after I exerted the force, which is this direction from here, B, you see that the Q3 is also coming what? Inside, like they want to come together. So I'll draw this two lines. This will be my F2, then this will be my F1. Then I'll just extend it and extend it here. Then I'll have my force total. So this is the force which they want us to what? To calculate. I don't know if it's clear until there. Is it clear? If there's any question. So yeah, so if it's not clear, you can stop me. So here, your first one is this one. Your first two is this one, which is created here. And now for me to have my first total, which is here, I have to add F1 plus F2, F1 plus F2 for me to have my first total. So here you're going to write this equation, which is force total is equal to F1 plus F2. And the F1, we have said, if you remember this formula, which I said this formula doesn't change. So you have to calculate your F1 first, and you also have to calculate your F2. Then after calculating your F1, F2, you now add them together. So your F1 is equal to K times Q1 times Q3 divided by R1 squared U R1, which is, this one is just a vector. So you don't need to panic to know what is R1, U R1. This one usually, it just shows the direction where you are going. So now they have given you your Q1 and your Q3. Since you are calculating for F1, so it means the charge which you are going to get is what? Q1, the charge which is the F1, this charge Q1 is the one which is creating, which is creating a force on Q3, or which is exerting a force on what? On Q3, which you have repulsion, which is F1, because they are positive. So this is Q1. So to be Q1 times Q3 for F1 divided by R1 squared. R1 squared actually is the distance AC, which have been already given here. The distance AC is 1.2 meter. R1 squared. So here, just replace, we have said that your constant, if you remember your notes, we said that your constant can be either 1/4 pi epsilon, or can be 9 times 10 to the power 9, which you are going to use here, 9 times 10 to the power 9, times 1.5, which is your Q1, times 10 negative 1, times 0.2, which is your Q3, times 10 negative 3, divided by 1.2, which is the distance between what? A, Q1 and Q3, which is SC, which is SC, they have given us SC here. Our SC is 1.2. So this is the 1.2 which you put here, 1.2.
Excuse me.
Yes.
Where does that 9 times 10 to the power 9 come from?
Oh, this is the constant. If,
oh,
yeah, I don't know if you remember.
Oh yes, from the formula. Okay.
Yeah, the formula. So constant is always this one.
Oh, okay.
Yeah, so that's where the 9 is coming from. Then these they have already given you. This is Q1, 1.5 times 10 to the negative 1, and the Q3, which is, since you are always exerting the force on Q3, so this is Q3 is 0.2 times 10 to the negative 3 divided by 1.2 squared. Then when you do your mathematics, when you punch on your calculator, you have 187,500. You have 187,500, which, if you want, you can just write it in decimal places, where since here you move, for you to have 1.875, just the same thing. You move 1, 2, 3, 4, you move 5 times, which is 1.875 times 10 to the power 5. You know how to do with decimals. When you move, you know, when basically here, since the number is really large, you have to write it in simpler form. Like the simplest form is you write it in a sort of a way of, in a sort of a decimal place. So you have 1.875 times 10 to the power 5. That's your first one. So you have found your first one. Then your first two is K, which is always the constant, Q2, Q3 divided by R2, the R2 squared. So you have, since you have seen here, Q3 is repeating itself. There's Q3, there's Q3 here. Why it's repeating itself is because the force is being exerted on Q3. So Q2 is exerting a force on Q3. That's why I've seen Q2 times what? Q3. So your Q2, you have been given your Q2 is negative 0.5 times 10 to the power negative 3. And your Q3 is the same one, your Q3 is the same one, which is 0.2 times 10 to the power negative 3, then divided by your R2 squared. Your R2 squared is the distance between B and C, which is BC. The distance BC, you have been given BC, which is 0.5 here. The distance BC, which is 0.5. This is the 0.5 here. This 0.5 what? Squared. Then you do your mathematics. Then after that, you have 3,600, which is your force, so force 2, which is, you just simplify it by writing it in decimal place, which is 3.6 times 10 to the power 3. Then you have found your force 1 and the force 2. So that's how you find. So it's just a matter of you just putting the figure. If you know the formula, you easily calculate it. Just the matter of you putting what the figure. So you have found your force 1 and your force 2. So after finding your force 1 and force 2, now you have to calculate your force what? Total. So how do you calculate your force total? So if you see here, this is the force total, and this force total is, I can say it creates something like if you see the way it is for you to calculate this force total, you have to calculate the module of this force, because it's creating something like if you see, it's creating something like a right triangle. So for you to know the distance which is here, the distance, the force which is exerted here, you have to know the you have to calculate its module. Its module, when I say the module, is just the same as Pythagoras theorem. I'm not mistaken, yeah, Pythagoras theorem. So here, since you are making a sort of a triangle where this one is F1, this distance is what? F2. Since the distance here and here is F2. For you to calculate this distance F, you have to use the module formula, which is the Pythagoras formula. So you have the module of F, which is F total, which is the hypotenuse in this case. So the module of F is equal to the square root of force 1 squared plus force 2 squared. You see that your UR, your U1 and your U2 will disappear. Why? Because we say that when you basically most of the time when you square the vectors, it always gives you 1. That's the rule. It always gives you 1. That's why you see them disappearing. So you just replace where there's force 1 with your force which you have found, and force 2 with your force which you have found. Then you do your calculations. Then you find your force total. Your force total, which is 187,534.5568 Newton, which if you simplify it is 1.875 times 10 to the power 5 Newton. So that's how you calculate the force. So for you to calculate the force, the things which you have to know is you have to check the charges. Are they the same charges? The charge which is being exerted on another particle, the two particles, are they the same? Is it positive or negative, or is it are they both positive, or is there are they both positive or not? Like you can have, are they both the same sign, or do they have signs which are contrary? So you have to be able to see that one first. So before you do your calculation, you have to study your diagram first. How is it? You study your question first. How have they asked the question? So from there, you can deduce how to calculate your your force, which is being exerted on one charge which you have been taught to calculate on. So I don't know if you have any questions here. Is there anyone with any questions?
Yes, sir.
Yes.
Just a general question.
Yeah, you can ask.
You're saying something like, you're saying that we are not allowed to use the point, or a decimal point, dot for writing the number. So instead, we're supposed to use a comma.
Yeah.
Is that what you're saying?
Yeah, that's what I'm saying. Like here in the French system, when you write a point, they'll think that you are multiplying, because basically they use a point, a dot. For them it means multiplication, but for you, like for them, I can say a comma is the one which means that you have how can I say in place of a dot, for you to have, for them, a decimal number, I can say. So a decimal number, they write it using a comma. When you see 1,5, it means they're just writing a decimal number, which is 1.5. And then when you see a point, you should know, like in this case, the point signifies multiplication. So most of the time the point signifies multiplication. I advise you to get used to this, because when you come here, you have some difficulties. You can calculate everything correctly, but due to you placing where you are supposed to put the comma, you're putting a point, you find that they can even mark your whole answer to be incorrect. So you should be careful. Should be very careful with the commas, the points, those things.
So on that, isn't that a bit of a problem? Because generally I don't know, like most people, we use the comma to separate, the large numbers. Like you can say 100,000, put a comma to separate, the hundreds from the one, that way. So they don't do that. They just write big numbers just like that without anything separating them.
Basically, like I've in French, I've never seen like them the way we do it. If it's a large number, for example, 1,000 is something. If this a large number, we do separate them with a comma. But here, I've never seen them separating with a comma. If they put a comma here, it means it's a point.
Okay.
If it's a large number, most of the time they just write it the way it is. If it's a large number.
Oh, okay.
But of course, the calculators, like when you're using the calculators, it's points. They use points. It's only when you are writing that's when you change your way of writing. You have to be using comma. But the calculators, there's nothing different. Like the ones which are using in Zambia and the ones which are using here, everything just the same. The way you go about it. That's why I was even wondering, why do they use commas? But on the calculator is when you're punching on the calculator is points, which we usually use, because that thing has never changed with calculators. So yeah, so we just have to follow them, because if you use your own way, they can't even mark you. And also the other thing, the Sokatua one, they don't know the Sokatua one. The Sokatua one, they don't know it. They use their own formulas which they use. So when you're solving, thinking in line of Sokatua, you don't need to write it in your book. You just have to think or write it. Don't have to write it when you're solving that I'm using Sokatua. What they don't know it here. They don't know there's no Sokatua here. They use there are some other things like some other equation which they use, but since for them, when you come here, you'll be learning with Moroccans, and Moroccans, they have learned, if it's mathematics, they have learned them from, there's those who are just specialized in mathematics, where you see someone had learned mathematics from childhood, and when the professor comes in class, the professor will just be teaching, and the professors, they teach as if you know the things. There are some formulas which you want to know where they're coming from. They just bring it and they start solving. So yeah, there are some things which you yourself, using your own knowledge, you can use. Like for me personally, I usually use Sokatua because that's the thing which I learned, but I don't write it when I'm solving. I just use it in my mind. I solve, or I just solve it like just aside. Then on the final paper, I don't put it, as long as the answer comes out. So yeah, so it's really important. Also the research, you have to do a lot of research when you come here, because the professors, they don't care whether you're followed or not. For them, it's going forward. That's why I tell you guys to do a lot of research. Like to do a lot of research, you have to get used with the system. So I've got the exercise 2. Exercise 2, we're still on charge punctual. So on exercise 1, I think there's no problem. So exercise 2, yes, you have.
You can go back for where you were solving for F2.
Where I was what?
Where you're solving for F2. Yeah, first. Yes. I know.
Yeah.
If there's a negative when solving, don't just discard the negative or just work in error.
I can't get your thing.
We were working with the Q2. Q2 is negative 0.5 times 10 to the power negative 3. Now the answer is positive. Did you just disregard the negative, or maybe it's just a working error? Because the final answer was giving me negative 3.6, not positive.
If you try solving it, it will give you negative.
There's a negative in the working here for Q2. Q2
Oh
is
yeah,
negative
I've seen it. Actually, it's supposed to be a negative.
Oh, yes.
Supposed to be a negative. Yeah, supposed to be a negative. As an error, but you see that when you see our main concern is calculating the first total. When you come to calculate the first total, you know that when you square a negative, it always gives you a positive, right?
Yes.
Hello, are you getting me?
Yes, I can get you. Yes.
Yeah. So so that was a small error, but it was supposed to be a negative. It was supposed to be a negative. But yeah, but when you come here, when you square it, you still bring you back to positive.
Excuse me.
Yes.
So for instance, in the same question, they ask to calculate the F2. So the answer should be left in negative.
If they told you to what?
To calculate the F2, then there's the negative there. So we'll leave the answer in negative form.
Basically for that, let's wait a bit. Basically, I can say the answer most of the time the force is, you can never find the force in a negative form. The force must always be positive. So I can say there's a step which I've missed here. That's why there's yes, like when you're solving, there's another step where you have to just wait a bit. I check for there's a PDF which I had made. Yeah. Are you able to are you seeing my sharing? Are you seeing my sharing?
Yes.
Yes.
Okay. Yeah, this is another PDF which I've made. This one is a bit, even though it's not clear, but it's a bit detailed. There's a step which, yeah, when I was trying to solve it today, I didn't include the step. So basically, when for example for F1, when you find your F1, you have 1.88 times 10 to the power 5, which is the F1 which you have found. UR1, which is times a vector. So for you, this is your vector F1. So for you to find your force is, you should know that force always is a module. So for you to find your force, your F1, it means you have to square root this answer which you have found. The square root of this answer to the power 2. And you know that if you square your vector, we say that it's always 1. So when you square this one, 1.88 times 10 to the power 5, when you square it, it will give you 1.88 times 10 to the power 5 Newton. It's the same with your F2 here. When you do your multiplication, it will give you here, it was supposed to be negative 3.6 times 10 to the power 3 UR, which is the vector. Then for you to find, so here you just you find when you're finding the vector force, you can leave it in negative. But when they have told you to find the force, not a vector force, a force is I can say it's a module. You have to your answer which you have found, you have to square root is to square it, yeah, and your answer must be to the power 2. You know how to calculate module, and your vector is just 1. So here, just the same, there's 1 here. And if you do, you see that when any number, as I said earlier, if it's negative, when you square negative, it always gives you a positive. So that's why you have 3.6 times 10 to the power 3 Newton. So if you are told to calculate just a vector force, you can have a negative, it's possible. But when you are told to calculate a force, just a force, meaning they want you to, what is the actual force like? You have to calculate its module, which is positive. So yeah, it's supposed to be negative. So I don't know if it's clear. The one who asked the question. So yeah, it's possible you can have a negative, but you can only have a negative when it's a vector force. When you have a vector force with an arrow per number, which shows that the vector force, it shows the direction of the force. You can have a negative, but yeah, the vector, yeah. But when you have the module shows the I can say the magnitude of a force. The magnitude is I can say the magnitude of the force. You don't need to include the negative. So it depends how they have asked you the question. Like for example here, they have asked you calculate the force result now. They've just asked you calculate the force. Basically, most of the time they ask you calculate the force result, those things. I can say in most cases, you have to leave your force in a magnitude form. A force, since force, the unit for force is Newton. You have to leave it in its magnitude form, which means your force will never be negative. It's always positive. Yes, you wanted to ask something?
Yeah, from the previous document. So the vector force for F2 is negative 3 point exponential 3.
Yeah, it's a
so
negative.
Include the negative.
Yeah, it's a negative.
Okay.
Then now when you're finding your actual force, your force, which is where there's no vector. If you have seen here, I've not written like it's not a vector force. You have seen it's positive. It has to be positive.
Okay. Thank you.
I don't know if it's clear.
Yes, it's clear.
Okay. So we're going to go to exercise 2. Exercise 2, we're still on charge punctual. Charge punctual is a charge which you can identify, which you can point out. Yeah, so example, the one which you are from seeing where you've got charges which are they are on a fixed point. You know where they are. They are identifiable. Like you can point them. You can easily identify them. So we're going to go to exercise 2, which is the charge punctual. So you start with the charges, positive punctual. Q1 is equal to 3 times 10 to the power negative 8 columns. So we have 2 charges which are positive. So we have Q1, which is 3 times 10 to the power negative 8 columns, and Q2, which is 6 times 10 to the power negative 8 columns. So fixer et maintenons à une distance D is equal to 0.5. So here they're saying you have got 2 charges which are positively charged. You have got what? 2 charges, two particles which are positively charged. You have got Q1, which is equal to 3 times 10 to the power negative 8 columns, and you have got Q2, which is 6 times 10 to the power negative 8 columns, and they are fixed at a distance which is what? 0.5. So the distance between the charge 1 and the charge 2 is what? 0.5 meter. Then now they ask you à quelle distance x de Q1 faut-il placer un charge negative? So they ask you a question is, at which distance x, a distance which you don't know x, of Q1 or from Q1, can you place a charge negative pour qu'elle soit en équilibre sous l'action des forces exercées par Q1 and Q2? So they're saying at which distance x from Q1, starting from Q1, can you place a Q3, a charge negative Q3, such that the action of forces, the forces which are acting on Q1 and Q2, the charges Q1 and Q2, when they act a force on Q3, they create an equilibrium. They create forces which I can say they create forces which I can say equal forces. And you know, if you have got equal forces, what usually happens is if you have equal forces, if the forces are equilibrium, what usually happens if you subtract those forces, it has to give you 0. That's what it's supposed to be. So they're saying you have to find a way of placing Q3 from Q1 such that the forces from the forces Q1 and the forces from charge Q1 and charge Q2 they are exerted on Q3, and those forces, they create an equilibrium. They create a balance. When they act on Q3, they create a balance in such a way that these forces, when they act on Q3, they cancel each other. The forces, when they act on Q3, they cancel each other, and a balance, you know, equilibrium, meaning it will give you equals to what? To 0. So now we are going to place Q3. We're going to do a diagram. So here they just gave us in form of writing. So you have to imagine, how do I draw a diagram? You have to imagine that. So yeah, so when it comes to a diagram, if you see your question is saying that if you see your question here is saying that à quelle distance x de Q1 faut-il placer un charge négative Q3? So it's saying at which distance x? At which distance x? So which distance x from Q1 should I place what? Q3. So there's Q1, you have what? Q3. So they're saying which distance what? X. This is x from what? Q1. Should I place Q3? In such a way that the forces which are coming from Q1 and Q2 are balanced, meaning they are canceling each other. So you have got a distance which is x from Q1, and they have told you that, if you see here, they have told you that Q1 and Q2 are fixed on a distance which is what? D, which is equal to what? 0.5 what? Meter. So if you have the distance from Q1 to Q3, which is x, it means that the distance from Q3 to Q2 is D minus the distance which is here, which is x. So this is the diagram which you have, and they have told you that Q1 is, if you see here, they have told you that the charges are positive. So Q1 and Q2 are positive, and they have told you that Q3 is what? Negative. So you have Q1, which is positive, Q3, which is negative, Q2, which is positive. And we know that the forces are exerted by Q1 on Q3 and Q2 on what? Q3. That's how the forces are exerted. So when you exert a force from Q1 towards Q3, you see that since this is negative, this is positive, you see that Q3 is like, it's being drawn to what? To Q1. And when you exert a force from Q2 to Q3, you see that Q3 also is being what? Drawn to Q2, because Q2 is positive, Q3 is negative. So that's why I've seen this arrow, which is, this is the arrow for the Q1, which is the force of attraction, and this is the R for what? I can say Q2, which is also the force of attraction towards what? Q2. And since Q1 is the one which is exerting the force on Q3, you see that you have to calculate the force for what? F1. And here, since Q2 is the one which is exerting the force on Q3, you have to calculate the force of what? F2. And the distance we have already, which is x, d minus what? X. So here they here they explain how you have to draw the diagram, which I've already explained. So they're just explaining how you have to draw the diagram, and they say la charge Q3 doit être placée à une distance telle que la force électrostatique exercée par le charge Q1 soit égale et opposée à la force électrostatique exercée par Q2 sur Q3. So they are saying that your charge Q3, as I said here, has to be placed on a point where you have to place at a distance where the force the force which is where the force exerted by charge Q1 must be equal and opposite to the force which is exerted by what? Q2 on Q3. So you have to place it here in such a way that you have to place it at a distance where the force which is exerted by Q1 is equal and opposite to the force which is exerted by what? Q2. That's what they are saying. You don't have to put Q3 outside here. Like when you put it outside here, it means Q3 is only affected by the charge which is Q2, because you have put Q3 outside. Imagine you put Q3 outside Q2, meaning the only effect, the Q2 is the only one which is exerting a force on Q3. Then the other way around also, when I try to put Q3 outside here on Q1, I'll see that it's only Q1 which is exerting a force on Q3. So the best thing is to put it on the middle so that both of them, they are exerting force on what? Q3. And we say that there must be equilibrium. So for you to calculate your force total is equal to F1 plus F2, which is equal to what? 0. Since it's in equilibrium, meaning your force one and your force two, when they come together, they cancel each other, and you have your resultant, which is what? 0. Since you need to have the force which is balanced, or the force which is acting on Q3 must be on equilibrium, must be balanced. So you have your F1 plus your F2 is equal to what? 0. So basically, most of the time when you see the word equilibrium on your question, you have to know that your sum of your forces must be equal to what? 0. Your force total must be equal to what? 0. So now you have to calculate your force one and your force two. So it's the same procedure how you did with how we did with the previous question. The same procedure. So you have to calculate your F1 and your F2. So your F1 is equal to here, instead of me writing K, I said K can be represented in two ways. You can write it either 9 times 10 to the power 9, or you can write 1 over 4 to the 1 over 4 pi epsilon. So here, it's better to write, since they haven't given us the values of X, the values of the distance, I can say so. They haven't given us the value of the distance between Q1 and Q2 and Q3, and they have just given us, I can say, variables like letters X, what. They haven't given us the actual value. So for you to calculate your force, it's better to use the one for 1 over, your K must be equal to 1 over 4 pi epsilon 0. But if you're given all the values, like if it's a straightforward calculation, you can just use that one, 9 times 10 to the power 9. Or if you want, you can use the 1 over 4 pi epsilon 0. So here they have used 1, K is equal to 1 over 4 pi epsilon 0. So you have your Q1 times your Q3, where is exerting the force, divided by the distance. The distance between here is in form of letter, which is x2. We don't know the distance, x2, with a vector. Since the vector is directed towards Q3, it will be U1. Then your F2, your F2 is Q2 times Q3 divided by 4 pi epsilon d minus x squared U2, the vector U2. Then from here now, you do your calculation. You just replace it where there is what? F here. You just replace where there F here. So when you replace it, since we have said that Q3 is negative, if Q3 is negative, you only multiply a negative and a positive, you will get a negative. So you have negative Q1, Q3 divided by 4 pi epsilon x2 U1 minus, since Q3 is negative, it will be negative here, minus Q2 U3 divided by 4 pi epsilon 0 d minus x squared U2 is equal to what? 0. So I'm just replacing on this equation. So when you do your replacing, you should also note that if you see here, you have U1. U1 is U1 is a direction. If you see the direction of the force which is exerted in Q3, there's this direction which is going is coming from the what? The is coming from the left side going towards the what? The right side. Yeah, it's coming from the left side going towards the left side. If you see your Q1 here, your Q1, the direction is from left towards right, and your U not Q1. If you see your U1, the direction is from the direction of U1 is from the left towards the right, and if you see your direction of U2 is what? From the right towards the left. So it's acting in opposite. That's why you have seen here. For me to simplify my things, I'll just say that I'll just say, if I want, I can say U1 is equal to negative U2 because they're opposite, or U2 is equal to what? Negative U1. So in this case, I'm going to use, in this case, I'm going to use U2 is equal to what? Negative U1. So if I want, I can use the first one, the U1 is equal to negative U2, either one which you want to use, but you just have to show that the vectors, the direction, they are in opposite direction. The vectors are moving in opposite direction. For you to show that they are moving in opposite direction, one must be positive, the other one must be what? Negative. So either one which you want to choose. So if you choose, like in my case, I choose the U2 is equal to what? Negative U1, which I'm just showing that the opposite of U2 is equal to, the opposite of U2 is equal to negative U1 because they are all coming back on the center, and you said that they are all in equilibrium. Then if you do so now, you just replace where there's U2, you place it by what? Negative U1. So you have U2 here. So here where there's U2, you place it by negative what? U1. When you place by negative U1, it will become what? Positive, since it will be positive Q2 times Q3 divided by 4 pi epsilon 0 d minus x squared U1 is equal to 0. So I don't know if there's anyone with any question until here. Anyone with any question?
And just repeat what you were saying.
Yeah, so if you see here the directions, there's U1 and U2. U1 is coming from the left towards the right, the direction, and U2 is coming from the right towards the left. So here, like, my main goal is for me to calculate X. For me to calculate X, I have to find a way of making my equation to have similar variables. So the first thing which I do here is, after I write my equation here, I have to check how can I make the vectors to be similar. So I know that these vectors are opposite towards each other, like they are coming opposite. They are opposite towards each other. And I know that if U1 is positive, U2 must be negative. If U2 is negative, U1 must be positive. So the positive and the negative, they are just showing the what? The opposite of these two vectors. So if you for example, U2. So I said for me, I'll use this one here, which shows that U2 is equal to negative U1. And if I use this one, it means where there's U2 here, I'll replace by what? A negative U1. So if I replace by a negative U1, it means negative times negative, it will give me positive. Then I'll have Q2, Q3 divided by 4 pi epsilon 0 d minus x squared U1. So if you have seen, I've introduced U1 and U1, which are equal vectors. So here, the main goal is first you introduce the equal vectors. So we want to calculate what for x. Then after we introduce the similar vectors, we can take one the other side. So here they decided to take positive Q1 and positive Q2, Q3 divided by 4 pi epsilon d minus x squared. They decided to take it to cross it over the equal sign. And you know that when you cross something which is positive over the equal sign, you're going to have a negative. And so here you have negative Q1, Q3 divided by 4 pi epsilon 0 x squared U1, which is equal to negative Q2, Q3 divided by 4 epsilon 0 d minus what? X2 U1. Then after I do this, I just do cross multiplication. I think from here is simple things like you just do cross multiplication. So if I do cross multiplication, I'll do this one times the down one here, the Q1, Q3, U1 times 4 pi epsilon, open bracket, d minus x, close bracket, squared. I do the cross multiplication. Then I also do the cross multiplication of this one, negative Q2, Q3 times 4 pi epsilon x squared. This is this is what you get here. Then when you reach this stage now, you can just do some division where you you can just do, if you see there's 4 pi epsilon 0 and U1, 4 pi epsilon 0 U1 and Q3, which are of the same value. So I can just divide by those values. 4 pi epsilon 0 U1, Q3, Q3, 4 pi epsilon 0 U1. If I divide by them, I only remain with negative Q1 d minus x squared is equal to negative Q2 x squared. Then from there now, I expand this one, d minus x. After expanding d minus x, I'll have something like d squared plus dx minus x squared, where plus dx minus dx will give you 0. So you just have d squared minus x squared. If I do, if I multiply with Q1, it will be negative Q1 d squared plus Q1 x squared is equal to negative Q2 x squared. Then you have seen there's x squared. I'll just take this one the other side. Then I do some factorizing. You have x squared brackets negative Q2 minus Q1. Then I'll just divide the negative Q2 divided by negative Q1, which is negative Q2 divided by negative Q1, this side and the other side. Then since this one will be x squared, it means I'll do square root here and square root here. Then since I've been given Q1, I've been given the value of Q1, which is here, the value of Q1, which is this value, and the value of Q2, which is this value. And I've also been given the value of D. So I'll just replace in my values here. I'll just replace Q1 is the negative 3 times 10 to the power negative 8 times 0.5 squared. then Q2 is negative 6 times 10 to the power negative 8 minus 3 times 10 to the power negative 8, which is equal to 0.289 meters. So the distance x is 0.289 meter for you to have the equilibrium. I don't know if there's any questions here. Is there anyone with any question?
Just kindly scroll up without writing. Hoping what's there.
What you're saying?
I'm saying kindly just scroll up a bit. No, down. No, down. The
Down again?
last step.
Yeah.
Yes. Again. Okay. Yes. Fine.
Please see. Yeah.
Yes.
You wanted the?
Yeah, just there. Fine.
What?
Just there is fine.
Oh, okay. Maybe is there somewhere where you wanted me to explain here or what?
Oh no, I was saying I was copying. I was writing down what's there. So I wanted to see.
Okay.
Understood.
I'll send the PDF to you.
Oh, all right.
Yeah, I'll send the PDF in the group. I don't know if there's anyone with any other question.
Excuse me.
Yes. Yes.
So do we all have to take this long procedure, or we can replace the numbers up there?
If you want, but if you place the numbers, you like it will be. You mean like starting from the first? I start placing the numbers.
No, not really starting from the first.
Because if it's like you say that in the case of placing the numbers, it will be very difficult for you to simplify your equation. It will be very difficult for you to simplify the equation. So the best thing, like with these questions, which they have got a lot of things to do, the best thing is you have first to simplify your equation. After you simplify your equation, that's when you can now put your numbers now, because it's really difficult for you to simplify. If you imagine you have placed 3 times 10 negative 8, 6 times 10 negative 8, and you are trying to simplify your equation, you have a difficult time to simplify it.
Okay.
Yeah, so the best thing is first you do it. Last, after you have simplified it, you just now put in the figures, the numbers, then you solve.
Could you kindly explain, like starting from here where it's written negative q1 d squared plus q1 x squared is equals to, like, how did we come up with a negative q2 x squared?
Well, here is where's negative q1 d squared plus q1 s squared
Plus.
or how we came about it. So basically, I said, after you have made your equation to be similar, you have u1. What you do is you just take this, you take one part of the equation and you cross it over the equal sign, which will be negative q2, q3, u1 divided by, I've just gotten this one here and I've taken the other side. So you have seen that it was positive, it will become what? Negative. Then from there, I just did cross multiplication, where I did this, the upper one, q1, q3, u1, times the down one when you cross the equal sign, which is 4 pi epsilon d minus x squared. This is the value here after I did the cross multiplication. Then also the negative q2, q3 times when I cross the equal sign, the value which is down here, 4 pi epsilon 0 x squared. This is the value which is this side here. So after that now, it's just a matter of now simplifying it. I know that I have 4 pi epsilon 0, and here also have 4 pi epsilon 0. I know that I have Q3, and here also have what? Q3. And I know that I have a vector U1, and also here I have a vector U1 when I cross the equal sign. So you see that I can easily simplify by eliminating the 4 pi epsilon 0, the Q3, and the U1. That's why here when I came here, I just divided. I divided 4 pi epsilon 0, U1, Q3, which you see Q3 will cancel out, U1 will cancel out, 4 pi epsilon will cancel out, which makes me to remain just with negative Q1 d minus x squared, which is equal to, if you see here, also you see that 4 pi epsilon 0 cancel out, U1 will cancel out, Q3 will cancel out, which will remain just with negative Q2 x squared, which is negative Q2 x squared, and negative Q1 d minus x, or negative Q1 open bracket d minus x close bracket squared. Then from there, you have to expand this one. The difference of two squares, is so for me to expand to be d minus x times d plus x. Then I do the multiplication here. So d times d will have d squared plus d times positive x, which will be dx, negative x times d, which will be negative dx, negative x times positive x, which will be negative x squared. Then dx, they'll cancel out because this one is positive, this one is negative, so they'll give you 0. So we only remain with d squared minus x squared. So negative q1 times d squared, it will give you negative q1 d squared. Negative q1 times negative x squared, it will give you positive q1 x squared, which is equal to negative q2 x2. Then from there, you just do your what now? Since you have seen the x squared, there's like term, and you are trying to find your x squared. So this the positive q1 x squared will go the other side. When it goes the other side, it will become what? Negative. When it becomes negative, you do the factorizing where you x squared, you remove the x squared, and when you remove your x squared, you have negative q2 minus q1. And from there, just divide by negative q2, negative q1, which is here, but negative q2, negative q1, the both sides here and here, which will be negative q2 minus q1. It will be negative q1 d2 d squared divided by negative q2 minus q1. Since here is x squared, I square root, and I also square root here. And from there, you calculate your x. Your x, you just replace where there's q1 and d squared and the negative q2 minus q1. This is the replacing which we did here. Then you have your final answer. I don't know if it's clear.
Yes, it is.
Yeah, so basically that's how you do with it. Yeah, that's how we do it. Yeah, and due to time, we were supposed to do one last example, but due to time, won't do it. Yeah, won't do it. Just try checking through it out. I'll send the PDF. Just try checking through it. Yeah. Okay, then have a nice day. Yeah, and enjoy the rest of your lessons.